Okay, good people, this video is on chapter 5, which deals with continuous probability distributions. The graph of continuous probability distributions is a curve. The probability represents the area under the curve, and the curve of the probability the curve is called the probability density function, and we abbreviate it as a PDF. We use the symbol f of x to represent the curve, and f of x is the function that corresponds to the graph, and we use that density function to draw the graph of the probability. So there's a couple of things that we want to remember. The outcomes are measured, not counted. The area under the curve and above the x-axis is always going to equal to 1. The probability is found for intervals of x values rather than the individual x values. And then if we are talking about a probability in between those two numbers, we want to consider everything to the right of C and to the left of D, meaning again, if we have the probability of C, which is less than X, which is less than D, we want to go in between those two numbers. And if our probability has to deal with X equals to a particular number, it is always going to be 0. That's because the probability is equal to the area, and the probability is also going to just be 0. All right, and if we end up with something with less than or less than equal to, it is the same thing. Now, I just want you to remember that when we're doing this continuous probability distributions, probability always equals to area. Now, I'm not going to go through all of these scenarios because you should be able to read some of your notes, but if I look at one of the scenarios before I do an example, let's look at scenario number 2, right? Suppose that we want to find the area between 0 and 2. So if you look here, I have it shaded in that this area, I want to find the area of this. So what I would do is figure out how much space is between 1 and 2 to figure out, because again, an area is what? Base times height for a rectangle. So I want to figure out how much is my base space, which is the reason why we'll do 2 minus 0. And then we want to see how much my height is. And my height is always going to be this f of x, right? And that is 1 over 20. So when we multiply it out, our area of this space is 0.1. Okay? Now, again, all of the different scenarios are about the same. You still, again, figure out what your base is, and then your height is given. And we go from there to find our area. Okay? So, if I do an example really quickly, it says consider the function f of x equals to 1/8 for 0 is less than equal to x, which is less than equal to 8. Draw the graph of f of x and then find the probability of 2.5 minus 7.5. So that means I am looking at a graph that looks something very similar like this. So it's going to go from 0 to 8. That is going to be my original box. All right. But, and then our f of x, which is always our y, is going to equal to 1 over 8. So this space over here is going to be 1 over 8. Now, it specifically says that we want to find this probability between 2.5 and 7.5. So I can roughly say that this is going to be 2.5 and this is roughly going to be 7.5. So I want to find the area in between these two spaces. Okay? So in order to find that area, I would have to do 7.5 minus 2.5, right? Which will give us 5. Yeah. And so for our area, again, an area is base times height. So that means we would do 5 times 1/8, and 5 times 1/8, I believe, will give us some nice good number. 5 times, and let me do it as parentheses 1/8 will give us 6.25 or 0.625. Okay. Now, as we continue on for most of our chapter, what we'll deal with in chapter 5, we have a uniform distribution, which is what I just did up above. And a uniform distribution looks just like this. It's a box shaped, right? And we want to find the area in between the shaded numbers, right? And it's a box. That's the best way I can put it. Okay, so the uniform distribution looks like this. Now, exponential distribution comes from the term of an exponential function, right? And exponential functions usually are drawn to some degree of that fashion, something going upward or something coming downward. Okay, and so this is what an exponential distribution would look like. And then we have a normal distribution. A normal distribution looks like this bell-shaped curve right here, and it's talking about the intervals in between these two spaces. But in chapter 5, we are really going to solely deal with the uniform distribution, okay? So, all right, the uniform distribution. The probability density function is f of x equals to 1 divided by b minus a for the inequality or interval between a and b. The formulas for the theoretical mean and standard deviation are given below, which would be a plus b divided by 2 and b minus a squared divided by 12. These again will be our theoretical standard deviation and mean. We usually derive this from calculus, but we don't need to derive them for this course. We only need to know how to use the formulas. The uniform distribution notation is given by x is equivalent to the uniform distribution of A to B, where again, A is going to be your lowest value and B is going to be your highest value of X, that is. And again, if we want to find that probability, it is f of x is d minus c. Again, d is the lowest value. D is the highest and c is the lowest. All right. So if we do an example really quickly, it says example number 2, the data that follow the number of passengers on the 35 different charter fishing boats. The sample mean is 7.9 and the standard deviation is 4.33. The following data of a uniform distribution where all values between 0 and 14 are equally likely states the values of A and B. Write the distribution in proper notation and calculate the theoretical mean and standard deviation. So if it go back and read through it, we say that it is going to have the following uniform distribution where all values are between and including 0 and 14 are equally likely. So it says state your A, state your B. So my A would equal to 0 and my B would equal to 14. Then the next part of it says write it in the proper notation. So our proper notation will be x equivalent sign of the uniform of 0 to 14, right? So if I want to find the theoretical mean, it says I need to do a plus b divided by 2. So that would be 0 plus 14 divided by 2, which will equal to 7. If I wanted to find the theoretical standard deviation, that means I would do what is it? B minus A. So that would be the square root of 14 minus 0 squared, all divided by 12. And if I put that in our calculator, that should give us the square root of 14 squared divided by 12. And that is 4.04. Okay? So, we'll do one more really quickly. It says the example, a distribution is given where x is in the uniform distribution of 0 to 20 and asks what is the probability of 2 to 18, and then it wants us to find the 90th percentile of that. So first things first, we would want to discuss what is our A and what is our B. Our A would equal to 0 and our B would equal to 20. Okay? So we need to find our f of x when we want to find this P of 2 to 18. So if you remember up above, right, we're talking about it's going from 0 to 20, right? But I want to find the probability between 2 and 18. I want to find that space. So if we're going to do that, we have to find our f of x. Now your f of x, if you recall at the top, our f of x equals to 1 divided by b minus a. So this will give us 1 divided by 20 minus 0, which should give us 1 over 20. Okay, so our f of x is going to give us 1 over 20, and that is going to be our height of this distribution. So now when we want to find this probability between 2 and 18, we can say that it will be, remember it's base times height or height times base, however you want to say it. So this could be 1 over 20 times 18 minus 2, because again, we want to see what the space is in between here. So that would give us roughly 18 minus 2 is 16. So that'll give us 16 over 20. And 16 over 20 as a decimal will give us 16 over 20 will give us 0.8. So 0.8 would be my probability or area underneath that curve between 2 and 18. Now, the next part of this says for us to find the 90th percentile. Now we have a little bit of extra work we're going to have to do for this one. So to find that 90th percentile, we need to first look at a few things, okay? So if we want to look at a percentile, this is an example where we are looking for a specific number, right? And if you remember what I said at the top, or no, I didn't actually say, but you got to read through some of your notes. This is going to deal with one of these where it equals to a number, okay? So if I look at this, this is saying the probability of C, which is less than X, which is less than D, right? And we want to figure out, and that equals to f of x times D minus C, right? So we are trying to say we want this to be in the 90th percentile, right? That's our probability, 90th percentile. So what's the probability that it's going to equal to 90? So our f of x, we know is going to be 1 over 20, right? And then we don't know the exact position of our D, but we know that our numbers start with what? C. And our number starts with C, meaning 0. It starts with 0. We're trying to figure out what that distance is to get to that actual 90th number, or 90th percentile. So now we just solve for our variable, okay? So if we solve for the variable in this case, that means that we are going to now have 0.90 equals to 1 over 20 times D, because D minus 0 is that. We multiply both sides by 20, okay? That cancels out. And then this will leave us with 18 equals to D. Move the decimal place over 2 times. Yep. So D equals 18. So our 90th percentile would actually equate to 18. All right. And then that is our answer. So I'm going to make this video really short. I just at least want you to have some gist of it. The only thing that I am going to ask you to do is to complete the next question, which will be a part of your video on D2L. That's it for me.